So yes, I'm going to move back to Southeast Asia now, and I'm going to give you a high-speed introduction to the variability across smallholder oil palm plantations and their management options for climate change mitigation. Okay, so as I'm sure all of you know, oil palm is one of the world's most widely grown crops, but 85% of this is grown in just two countries, Malaysia and Indonesia. And its production is split around 60-40 between large commercial operations and smallholder farmers. The commercial plantations are large in scale. They generally follow industry best management practice, and a growing proportion of this production is certified as sustainable by international bodies such as the RSPO. But smallholder farmers, on the other hand, are defined, at least in Malaysia, as those managing less than 50 hectares of land, but typically they will manage only a few hectares. And they're hugely variable in terms of the way that they are managed. And as you can see from the pictures here, these are some pictures from some of our work in Perak district. And you can see that we've got cattle grazing in oil palm plantations. We've got complex, diverse understories or bare soil with no understory at all, and oil palms that are well past their productive peak. And only a very small fraction of this is certified as sustainable by international bodies. So here we have a schematic of a typical commercial plantation. So we have the palms shown in blue here at even spaces, and the white areas cleared of understory vegetation. And in these operations, we have palm planting densities that are well defined, and fertilizer application is balanced to meet palm nutrient demand. However, across a survey that we conducted across Perak district of the Wild Asia Group scheme, we found that many farmers, smallholder farmers, planted their palms at a too high or a too low planting density, as you can see from this graph on the left-hand side. And this has long-term implications for the productivity of these plantations. And on the right-hand side, we can see for the rates of fertilizer addition across these same plantations, we again found a huge range of application rates. So on the y-axis, we have the fertilization rate, and on the x-axis, sorry, and then on the y-axis, we have the nutrient, nitrogen, potassium, and phosphorus. And we can see that these smallholder farmers generally underapplied potassium and nitrogen, which has impacts upon yield, and overapplied phosphorus, which has implications for the farm profitability and environmental quality. So, as you may imagine, this variability in the way that these plantations are managed has implications for yield. And so on the right-hand side here, again, for these same farms, we can see a massive range from low yields all the way up to highly productive yields. But typically, smallholder plantations are yielding around 35 to 40% lower relative to their commercial counterparts. But low yielding plantations, of course, require more area per unit of oil produced, and therefore improving smallholder productivity through sustainable management strategies is an essential tool to meet future demand whilst avoiding further expansion onto high carbon stock lands. And these may also deliver further benefits in terms of climate change mitigation by enhancing ecosystem services such as soil carbon stocks. So, as we've seen, there's great potential to improve the management of these smallholder oil palm plantations. And if this management follows sustainable agricultural principles, this can result in significant environmental benefits, both in terms of climate change mitigation, but also enhanced biodiversity, as well as the socioeconomic benefits, such as increased yields, greater farm profitability, or diversification of farmer income streams. And over the next 3 slides, I'm just going to give you a very quick overview of some examples of the type of plantation management that could be more widely applied in the smallholder context, such as recycling of organic matter waste streams, changes to the way the understory vegetation is managed, and a transition toward diversified cropping systems. So the first example here that I've got is crop residue management. So as the crude palm oil, which is taken as the final product and leaves the mill, is very low in nutrients. And so most of the nutrients removed from plantations during harvest operations actually remain behind in the empty front bunches and in other mill waste streams. And these can be returned to plantations to meet part of the palm nutrient demand, offsetting the need for mineral fertilizer. And this is practiced widely in commercial operations, but is far less common in smallholder systems. And these waste streams can either be returned as they are and composted on farm, or where the distance to the mill increases transportation costs, they can be first processed into formulated biofertilizers or pyrolyzed into products such as biochar, which is a stable form of carbon, which can promote nutrient retention and enhance soil carbon storage. And secondly, the current frond stack management practices, which consists of piling dead and pruned fronds in interrow areas, is not efficient to integrate the organic matter from these fronds back into the soil. And by chipping these in situ and composting alongside other waste streams, this can improve the integration of this organic matter into the soil surface. So in summary, by closing the loop between the farm and the mill, there is real potential here to enhance soil carbon storage and reduce the use of mineral fertilizers and their associated greenhouse gas emissions, particularly of nitrous oxide. And there's also potential to improve yields through enhanced soil structure, nutrient availability, and nutrient retention. So the second example is to alter the way the understory vegetation is managed. So the typical management is shown in the bottom left of this slide, is maintain a weed-free palm circle and harvesting paths for harvesting operations. But many farmers also apply herbicides liberally and will clear most of the understory because of a perception that the understory vegetation competes with oil palm trees for water and nutrients. But in fact, maintaining a more complex understory, such as that shown on the right-hand side of this slide, or switching from chemical to mechanical forms of weeding, can actually stabilize soils, thereby reducing soil erosion and nutrient leaching. It can enhance soil biodiversity and potentially soil carbon storage. And it can also act as a form of biological pest control by promoting healthy communities of invertebrates and microbes. And it can also reduce emissions from the production and usage of agrochemicals, which also has important human health benefits as well. And the last example I'm just going to very quickly touch upon is diversification of production systems away from purely monoculture plantations. So annual or short-lived perennial crops may be intercropped with oil palm at early stages of plantation establishment. So we've got an example here on the right-hand side where papaya is intercropped with juvenile oil palms, or palms may be permanently planted in combination with other perennial cash crops such as cocoa, fruit trees, or rubber. And again, these practices may have benefits for soil stability, soil biodiversity, and carbon stocks, and promote above ground biomass accumulation. And they can also reduce the dependence on agrochemicals and particularly have potential to improve oil palm yields, especially where palms are grown outside of their ideal climate and soil conditions. And these mixed cropping systems also reduce the socioeconomic risks of farmers of depending on a single cash crop. And lastly, it's just important to highlight that there's a number of challenges that exist as barriers to the widespread implementation of these sustainable management. Smallholder farmers really can't invest in long-term solutions if they don't generate a short-term return on their investment. And kind of international markets could provide a funding mechanism here through schemes such as payments for ecosystem services. However, carbon accounting is very difficult in the smallholder context due to challenges in traceability and the huge variability in the management practices. And so there's really a need to balance the smallholder needs at a local level with ecological aims at the global level, such as forest conservation and climate change mitigation. But ultimately, the transfer of knowledge and innovation to smallholder farmers remains one of the main challenges facing the sustainable management of oil palm. And this is why the work done by organizations such as Wild Asia is so important to facilitate this knowledge transfer between academia, industry, and the smallholder farmers themselves. Thank you very much.